Okay, all right. So today, I will start with the file handling, and after that, we'll also discuss some of the concepts in multi-threading. Okay, so file handling, right? So as the name depicts, file handling means the different files which we can create, edit, modify, delete, or move using C hash. In general, normally most of the times applications deals with their own backend database to read or write the data. So whatever the data you wanted to store for your application, predominantly use a backend database. Mostly it is a SQL Server or Oracle. Okay, so mostly nowadays, because previously when we have no database concepts, right? No DBMS. That time we were, applications were heavily using the files to store the data. But since files has its own disadvantages, people started using databases. Okay, but still there are some scenarios where you need to create the file. Okay, so those scenarios are basically, see, if you see you have your application, okay, let's say the banking application, and you have your own database in the backend. Okay, and the same way you have insurance, let's say insurance. Okay, or let me say banking, and I will say this is credit agencies. Okay, so you have an application called banking, which has its own database, and we have credit agencies, it has its own database. Okay, so now within the application, you're fine. You're directly hitting your database and writing or whatever the data you wanted to do, you're doing it. It's fine. But suppose if there are a scenario where you want to send the data from one application to another application. Okay, okay, so in these cases, if you want to move pass the data from one application to another application, okay, so the example is, let's take the ICICI Bank. Okay, there are thousands or hundreds of people who uses the credit card and every day. Okay, and some people may miss the payment on time. So what happens whenever there is any default on the credit card, every bank has to report that default reporters list to the credit agencies, right? We have credit agencies, do you know, like we have this Equifax, CIBIL score, CIBIL score, right? So basically this is the credit agency. What they do, they get the data from all the bankings, okay, and they load into this credit agency application. That way they know that who are all the defaulters. That way they can accordingly apply the score for their CIBIL. So now let's say, ICICI Bank has to send the daily feed to credit agency, which contains the credit card defaulters list. Okay, let's say this database is in Oracle. Okay, and this database in SQL Server. Okay, so the different databases. So ideally, what happens is whenever we deal with a different one application to another application or one DB to another DB, we don't have a choice of directly writing the data into their server or their application, because normally we are outsiders, right? So they have so many banks trying to hit credit agencies. So this application doesn't have authority for all the banking applications to directly write into their database. So what they do, they say, hey, you give me a file on every day, okay, on every night, okay, and they say, I need this file in some format, okay, some fixed format. They say you give me the file in that format, and I will load into my application and I will run my own script which can load the data into my backend. So basically we are acting, this file is basically we are creating as an intermediate resource which can be fed into credit agencies. Credit agencies can read this file and write into their own database. It's kind of a pass through. Okay, so this is the real time scenario where you use the files. if you want to move from one application to another application. So uh, here CHash provides a lot of classes to handle with the file operations. Okay, so the I will start with a couple of important streams. Okay, which is called stream writer and stream reader. So stream writer is a class which is used to write the data into a file. Okay, so the stream writer has a class called write to write the data, write line. It writes the data, okay, and also gives a new line character at the end of the. Basically, it's a new line. And flush is to clear the buffer and permanently write into the file. Close is to close the stream writer. And it's in the same way, stream reader also to read the data from a file. You can read one character at a time. You can read the entire line using read or read line. Seek, you want to locate or you want to read a specific location value. Okay, peek if you want to return the next available character, and close. So there are several methods this stream reader and stream writer classes provides. Okay, I will give you one example like how to read and how to write using stream writer and stream reader. Okay, so one important thing you need to remember is that all these file operations, right? The classes associated with the files are stored in system.io namespace. So whenever you are handling the file operations, okay, you have to include this namespace system.io in your programs. Otherwise, you get the error. Most of the file related uh, classes, properties, or methods, it contains in system.io namespace. Okay, so stream reader writer and stream reader. So initially, when the CHash is introduced, right? So that time, they have this stream reader and stream writer. But in the later versions, they simplified the options of writing or dealing the files, which I will show you in the next slide. But I will just take one example to show how this stream writer and stream reader works. Okay, you see, I am here in this program, I'm trying to write the data into a file. Okay, and you see, I have included system.io. It's a mandatory because that's where all your all your classes or methods or properties included. So the moment I comment the system.io, you see that I'm getting some errors. Okay, you see this stream writer could not be found because stream writer I am using in my program. This class is only available in system.io. It says it is not found because I have commented this. Okay, so now here, if you want to write the data into a file, okay, I am using stream writer class. Okay, it's a new stream writer. I'm creating SW is my object and I'm passing the file where you wanted to write the data. It's in D drive tetra.txt. Let me see if the file is there. Okay, it's not there. Okay, so here on the console, I am asking the user to enter whatever he wants to type in the tetra.txt. Okay, and then I am reading that content, whatever is there on the console, I'm reading and storing in a string variable. Okay, and so you have the data available in the string variable. Now you need to fed that data into the buffer. Okay, so normally what happens is whenever you write the data, first you have to read the data, store it in the buffer. When you say flush means that time it will write into the actual file. Okay, so remember, write line doesn't write directly into the file. It only writes into the buffer and you have to say flush to write into actual file. And once you have written, you can close the stream. So very simple. You're creating a class for stream writer, okay, and you're reading the data from the screen, from the console. You are writing into that particular object, stream writer object SW, okay, and then you're saying flush. So once it is written, you're saying close. So all the predefined methods I'm using it here. So if you see here, okay, so it is asking to create, to write some text. Okay, just type or something. I'm hitting enter. Okay, so it's over. Now let's see. Okay, it's there. You see, tetra.txt file has been created. Okay, so first, this is what I have entered. And if you see the script, after this, I have added one more line. Says he's saying end of file. I add one more statement, hard coded statement. So that also added here. And when I say flush, it has written into this file, then closed it. Okay, this is simple how to write into a file using stream writer. Okay, yeah, so similar way, if you want to read the data from a file, you have one more class called stream reader. Okay, so I'm trying to use the same file where we have created the data now here, but I'm saying stream reader. Okay, and you see, I'm using a method called seek to say like now from where I wanted to start reading the data. Okay, I said zero, from zero position you start. Okay, right? And whatever the data is there, I am moving it to a string, and that string I'm writing on the console just to see that like how I'm reading and printing on the screen. Okay, so the first one is stream reader. You have to create a class object for a stream reader and may mention from where you wanted to read the position, then read the data and store in the string and print the string up to you find this, there is no more data to read. Okay, so contents of the file is the one I have entered here, and these two lines have been read by the stream reader class object, and there is no third line, so it becomes null. So it came out of the loop and printed. Once I enter it closed it. So it's like there are a lot of classes like this: stream reader and stream writer. Okay, and text reader, text writer. But like these are all the initial days we used to use these classes. But in the later versions, as I mentioned, we have more sophisticated classes available. Okay, and those methods are available in the file class. Okay, so the file similar to stream reader class and stream writer class, we have one more class called file class. Okay, and this is the heavily used class in nowadays. So it contains several static methods to do all kind of file operations: reading, writing, deleting, appending. Okay, and again this file class is in system.io namespace. And if you see, reading, writing, appending. Reading means to read the data, writing to write the data, appending means you want to add additional text to the existing file. Normally whenever you say writing, right, it overwrites the previous data. But when you say appending, it is additional data you are going to write into the file. Okay, so there are several methods available in CHash. Okay, so uh, You just need to remember the important ones, okay? But it provides lot of options. So you don't really need to remember all these methods, but just have a glance at those methods and see what each method does. Because when you start dealing with files, these methods may be useful, because of your specific scenarios. You may need to use these one of these methods to achieve your desired results. But I will just focus on the important methods where we require for reading or writing. Okay, so let me take you the example for class, file class. Okay, so here if you see, again I have included system.io. Okay, and I am setting there is one string I am creating file path to store the path of my file. Okay, do we have that file, my file? Yeah, my file is there. Okay, and see, I told there are a lot of static methods available in the file class. So I am using this file class exists. Okay, it's a static method. That's why I'm using directly with the class name dot method. So if the file dot exists, so what is the file? Whatever you mentioned in the file path. If this file exists, I'm saying just to say that the file is available, otherwise file is not available. Just I'm introducing here first method, it is called exists, whether it is exist or not. Okay. So since we have the file already exists, it reads and says text file is already available in the D directory. Okay, so it's a exist method. Let's try to read, that way, read and read. That way it will be easy. Okay, so let's try to read here. Again, I have a string variable to define or to store the file path. Okay, and I'm using the file exist method to see whether the file is available or not. If available, okay, see, I'm using a method called read all lines. So it simply reads all the lines of that file, okay, and stores those lines in a string of lines. Okay, so lines is an array which can store the string type values. Okay, and if you have 10 rows in your file, so this lines array will contains 10 different indexes 0 to 9, and you can once you store those lines in here in the string, you can print it here. Okay, if you see here, okay, let me see what is there in the my file. Okay, so it has couple of statements and it printed this couple of statements. So you see, previously we were writing, a lot of code, but here I just used only one method, say read all lines. Everything came into a lines array of string type. And you're just using, write line command to just print to see whether you really read the data or not. So the class file class simplifies the way you handle the things with the files. Okay, so most of the code is already, or most of the methods are already predefined and available in the class. Okay, you just need to understand the different methods and try to adapt or implement in your programs. Okay, let me take you one more example. Let me see what else I have written. Okay, so this is basically if there is, I think it's as good as the same class, same method, but if there is nothing, it will say there is no file available here. Where did I went? Okay, folder selected. Let's see file copy. So this here I'm just trying to copy one file to another file. Okay. So here I have my source file and I have my target file. Okay. And if the source file already exists, if exists, okay, I'm saying file dot copy. So I mentioned like no, there are a lot of static methods available in the file class. So class name directly because static class you cannot instantiate. So file is a class dot copy method. I'm saying the source file and the target file. Very easy. Okay. And then after that, I'm just reading the data from the target file. Okay. And I'm printing it on the console. Okay. Let's see if the file has been created or not. Okay. So it got created file cop my file dot copy dot text. So, I mean, basically what I'm meant to say is that like, there are a lot of methods available in the file class. Just to go through those class and try to familiar with this, like now try to write small programs, okay, and how you can handle these methods and be familiar with this class and methods. Okay, so remember guys, this is in your real-time programming, the chances are very high that you will use the files. Okay, and I have given you the real-time example where you use these files. Okay. Any questions on the files? Okay, so we'll move on to multi-threading. Because this is also one of the very important concepts, not only in CH but in any programming language. Okay, so before okay, so multi-threading, right? So normally, uh, whenever computer, uh, okay, so let's say we have our computer, okay, and we have things called processes. Process means, see here, if you see my application, right, my computer, okay, I have opened one PowerPoint, okay, and I have opened the Visual Studio, okay, and I have opened one spreadsheet, right, and I have opened my Zoom also, okay. So computer is one, but I have multiple processes. So the same CPU is trying to run more than one process in the backend. It is called typically it is called multitasking. So that means one computer doing multiple things. Okay, it is trying to see whatever I am entering in the spreadsheet. Okay, and if I say it will save it, and I have PowerPoint, I have Visual Studio. Okay, I'm also using Zoom meetings. Okay, so here All these are called processes. So one computer trying to handle multiple things, right? It is looking at the spreadsheet, it is looking at the PowerPoint, looking at the Visual Studio and Zoom meetings. And whenever you say save or edit or something, it again, a computer recognizes and does the certain kind of operations. So this is called multitasking. So computer is doing multitasking, right? More than one task. Okay, so these are called processes. Okay, I think the best example you can see is that like when you open this, okay, I have here only task manager. If you see here, right? You see this processes, right? So it shows I have two instances of Zoom running. I have Windows Explorer. I have Task Manager. I have Visual Studio. I have Edge. I have Office. So it shows that like, computer is trying to work on 7 different processes, which we are aware. And the backend, there are a lot many are going on, but right now I'm focusing on this process. So what I'm trying to say is that, if one person does multiple things at a time, it is called multitasking. Okay, so now when I say multi-threading, right? Okay, multi-threading means, okay, so before that, what is thread actually, right? Suppose you are writing a program, okay, you are writing a program and you're trying to execute. So normally what happens, it will just execute the program. It goes to the main method and tries to execute the statement one by one, step by step, right? So basically I can say that, it is trying to execute a predefined set of statements from beginning to ending, right? It is called a method. Okay, it's a unit of work, a unit of a process that is responsible for executing the application code. By default, whenever you write the program, okay, it is it is a single thread application. Okay, it is a single thread application. You see here, okay, so here it is a main method. I have three methods, method 1, 2, 3. Method 1, I'm trying to print something. Method 2, I'm trying to print something. Okay, and in method 2 I have a sleep statement. Right, sleep means it waits for the predefined time whatever we have given. It doesn't do anything, program just simply waits. And method 3 also I have. Okay, so there are three methods. Okay, so let me put a breakpoint here. Okay, F9, and I'm trying to run it. Okay, it stopped here. Okay, okay, let's see. Debug Windows threads. Debug Windows threads. Okay, so I told by default we have only one thread. Okay, you see this main thread. So clearly saying that like your program is a only one thread application, single thread application, main thread. Okay, so if you try to execute this program, right? Okay, you see method 1 got executed. Method 2 also we have 1, 2, 3. Okay, and after printing 3 times, okay, it went to sleep for 10 seconds. Okay, let's wait for 10 seconds, then it will complete the rest of the stuff. Okay, you see after method 2 executed 3 times, we have a delay of 10 seconds. Okay, after that we have method 2 completed for remaining 4 and 5, and then method 3 executed. So here the thing you wanted to understand is that in a single thread application, the control flow starts from the main method and it will simply execute one by one. Okay, method 1, after the completion of method 1, it comes to method 2 and then method 3. And if there are any kind of wait, or if you are doing any kind of heavy operation, okay, so method 3 waits for the completion of method 2. There is no way you can abrupt method 2 and execute method 3. It has to go sequentially. So the problem with single thread application is that, okay, it will execute from the top statement to bottom. Okay, and if there is any dependencies, it waits for the dependent method, because method 2 is waiting for some time. So method 3 is waiting for the method 2 to complete. Okay, so this is the biggest problem with the single thread applications. But let's say, like, you have a scenario where you really do not need to wait for the method 2 to complete. That means you can execute method 1, you can execute method 2 and method 3 at the same time. You don't need to wait for method 1 to complete for method 2 to invoke, and same way method 2 to complete to invoke the method 3. You can simultaneously, at the same time, you can execute these 3 methods if you want. Okay, so if you want to do like, executing different functions at the same time, you can use multi-threading. You can assign one thread to one function, second thread to second function, third thread to third function, and say, like, hey, like, just run these 3 methods simultaneously. Okay, so that's where, like, we use the multi-threading. Okay, so I said drawback of single thread applications: code is executed in a sequential order unless previous set of statements are not executed. Current statement doesn't get invoked. So how to resolve the problem? We have a concept of called multi-threading. Okay, so in multi-threading, right? Okay, so operating system has a process which I shown you, which is used to run the applications. Okay, and process contains thread which will actually run the application code. A process by default makes use of single thread application. Okay, and now you're trying to use a multi-threading concept. So multi-threading is a mechanism to implement concurrent programming. Concurrent, like simultaneously, more than one thread can work. Okay, so the biggest advantage is that, like, since you have a good amount of infrastructure available in terms of memory, servers, or CPU, if you have this multi-threading concept, you can effectively utilize your server infrastructure, because your infrastructure is very high. You have a lot of servers, you have a lot of memory, you have a lot of CPUs. So if you are executing a single thread application, you are underutilizing your infrastructure. So you can use this multi-threading concept and you can effectively utilize your infrastructure. Okay, so that's all about the threads. Okay, now let me show you the multi-threaded demo. That way, like, okay, so before that, right? So basically, if you want to use the threads in C#, you have to use this thread class. Okay, so you can create foreground or background threads. Foreground means which you can rarely see. Background means these ones. This Windows shell notification and widgets. Some are running backend, which we are not aware. It's kind of a, the batch. We can only see these. When I look at my computer, I can only find these applications. I cannot find these things. There are so many things going on here. So it's called backend, and these are called, okay, the forend. Okay, so we can create foreground and background, and you can also set the priority. So if you have, like, more than one thread and you know which method is important for you, you can give a high priority for that particular thread, so that that thread gets priority to execute. Okay, and you can also identify whether thread is still active or it is, completed executing or not. So you can identify the state of the thread. Okay, and thread is a sealed class. You cannot inherit because that's how it is, right? Okay, so now let me show you one example. Multi-thread, right? Okay. So now if you want to create threads in your program, you have to use a thread class. Okay, so thread class, you're instantiating a T1 object. Okay, and you're saying method 1. That means for T1 method, invoke method 1. For T2 method, invoke method 2. For T3, invoke method 3. So remember guys, you're only instantiating the threads. You have not kickstarted your threads. If you want to kickstart your thread, you have to use T1 dot start, T2 dot start, T3 dot start. That means these three threads will start one after one. Okay, and all three will try to execute simultaneously. It doesn't wait for the T1 to complete. Okay, so T2 doesn't wait for the completion of T1. T3 doesn't wait to complete the T2. So all three will be simultaneously executes. If you see here, right? So I have main thread. I have three different threads. Then you see, I'm just to identify which thread got invoked. I'm saying okay, thread dot name to give what is the thread name, T1 or T2 or T3. Okay, so let's see here the same piece of code which we have written for the single thread. I'm trying to execute here. Okay, so you see here, see I said T1, T2, T3 simultaneously, right? If you see what happened first, main method started and ended. See, first method 3 executed, method 3. Okay, then method 1. Okay, then method 3, 1 2 3 4 5, and method 2. You see it is not in a sequential order like method 1 2 3 4 5, method 2 1 2 3 4 5, method 3 1 2 3 4 5, right? It is executing on their own way. Method main method started and ended, method 3 started, then method 1 started, then method 3 printed, then method 2 printed. You see it's all because all three threads trying to run on their own. Okay, there is no dependency to wait for any other threads. Okay, so it may not be the same behavior when you try to run the next time. It may go different also because it all depends upon the server, the infrastructure availability, okay, of your application or the servers. Okay, see it executes differently whenever you run at different times. It all depends upon the infrastructure. So what I'm trying to say is that you are trying to kickstart the threads at the same time without any dependency. Okay, okay, so this is a simple example I have shown. Any questions here, guys? Multi-threading, it's very important topic actually. Okay, so I just wanted to hear from you, like whether you're able to understand or not. Say yes or no. From last 2 or 3 classes, like everybody is silent. I'm just like now I'm just explaining and I'm not able to understand whether you are getting it or not. So can someone unmute and say whether yes or no, whether you are able to get these things?
Yes or no? And
Okay.
our most of the students are learning from the recording sessions. Like they are not good with the
Oh,
timings, right? So they are learning
okay.
from our recording sessions.
Recordings. Oh, okay. Okay. Fine. Then if it is fine, yeah. Okay. So let me show you one more example. Okay. Uh, so here one more class. Okay, I have two different files here. Okay. So here the class is number helper. Okay, and I have one constructor. to load the value, and I have one method called display numbers, okay, to print 1 to whatever the number I have entered, 1 to 10 or 1 to 15, just to print the numbers. Okay, this is the class is helper, number helper, and my method is display numbers. Okay, and here I am created a object for the number helper, and I'm passing this 10 as a constructor parameter 10. Okay, and I'm creating a thread, and I said t1 dot start. So here one thing you need to remember is that through constructor I am passing a value of 10 to the class, okay, here, and the constructor is loading that value, and that value is getting passed or being used by the method display members method. So indirectly I am passing a value to the constructor, and it is being consumed by your method, right? So that means there is a way you can pass the value to a thread, right? So let's see. Okay, so you passed one or 10 number to a constructor. Constructor read that and pass it to that method. And when I invoke the thread, okay, it picked up the 10 value and started printing from 1 to 10. Okay, now I wanted to tell you one thing. Okay, in the previous example there is one drawback. Okay, I wanted to show you that. If you see here in the multi-threading application, okay, you see here if you see they have three threads, t1 t2 t3, right? But if you see the main method started and main method ended, after main method completed, then you have your threads started and completed. But ideally, like in a programmatic world, right, you expect the threads to complete before wrapping up your program, your main program. Okay, I repeat, in general in our computer world, right, in your programming, okay, because you wanted to end your main program only after the completion of your threads. Okay, so that's why, like, you need to ensure that your main method is still active unless and until all the threads are completed. Okay, so that can be done, okay, by using a word called, okay, join. Okay, let me show you the, okay, I'm writing. Okay, let me show you the how to use join method. Okay, so here you are creating three threads, okay, and you are starting the three threads. Okay, you use this word join. Okay, join means you are joining these three methods, so you wait for these three threads to complete before ending your main thread. Okay, so join blocks the main thread until thread 1 completes. If you see here, see main thread started, method 3 2 1 started and ended, then finally main thread ended, right? So if you want to create a scenario where you wait your main thread to complete for the remaining threads, you have to keep this option called join. Okay, let me put a breakpoint here. What's happening? Okay, it's override. 1 second, let me. What's happening? Why it is not showing? I just wanted to show you that, like, no, about these threads. You see thread 1, thread 3. One second, guys. I wanted to show you something. You see here, it shows the threads. Main thread, worker thread, worker thread. So I mean, basically, what I'm trying to say that you can see the threads here. You know, whenever you have multiple threads, right? You can see it. You know, using that debug windows, and you know the threads here. You will see, right, whenever you are in debug mode. So you can see those all the threads. Okay, so that is the way you have to use the join. Okay, and if you wanted to know the current status of thread, whether the thread is started, in progress, or completed, if you want to get that, you can use one more method called is alive. Okay, if you see here, okay, so you have started thread 1. Okay, and okay, here thread 1, you are, you know, because the method 1 is the one you are using to invoke for the thread 1, and you wanted to put a sleep, you wanted to put a sleep for 2 seconds for the method 1. That way I can show that, like, you know, this is alive method is working, property is working, because it will start, thread will start here, it will come here, and there is a 2 seconds of delay by the time it will execute this. Okay, and the thread is active because I purposefully hold it for 2 seconds. So is the thread is alive? Yes, thread is still running, so it will say thread is still executing. So that is one more method you can use, property you can use. Okay, see, thread is still executing, is alive, is alive, and join, right? Okay, so typically, like, you know, now you know that, like, you know, you have a multi-threading concept where, okay, you can execute different functions based on your need. That way you're, you know, enabling the parallel processing, more than one task being executed using multi-threads. Okay, so guys, one thing you remember here, For each method, each class, whenever, sorry, each object I'm creating for a thread, I am passing method as a parameter. Okay, remember, I am passing a method as a parameter. So if you try to recall your memory, when we discussed about events, right? Events, delegates, and event handler methods. Using delegates, we used to pass the methods. We used to pass the methods for the object. So to recall your memory, whenever we are passing the method as a parameter to a object, okay, it is indirectly using the delegates. Okay, so the object is using a function to invoke to kickstart the process. So those are normally done in the delegates. So delegates always takes the method as a parameter. Okay, and whenever we use delegates, okay, there is two more things comes into the picture. Okay, one is one is you know the anonymous method. One is lambda expression. Just try to refer back the text, the material I have provided. Okay, so you create a thread and you have a method to execute. This is the regularly you are like creating a delegate and invoking a method by passing the method name in the delegate. But if you use anonymous method, okay, we don't need to explicitly mention the method name, but simply mention the word delegate. When you say delegate word, internally the, the CLR creates their own method and keeps this logic in the method. But when you use lambda expression, that means there is nowhere you will mention about the method. Okay, if you see you are like nowhere you're mentioning the method name, simply you're writing your code. Okay, so lambda expressions are used whenever you have an opportunity to pass a method for a object reference. That is nothing but whenever you use delegates. So what I'm trying to explain here is that threads, all the threads, they use delegates internally because you are passing a method for the threads. Okay, so whenever you use delegates, you can have your own explicit method to kickstart. You can have a anonymous method by using delegate keyword, and you can have lambda expression where you don't mention the method name at all. Okay, it's very important, guys. Okay, so so there are a lot many properties you can go through. There are different properties of a thread class, different methods of a thread class. Okay, and I explained about this delegates. Very important actually. Okay, now coming to the thread synchronization. Okay, I will just explain the theory part and probably we can stop here. So thread synchronization. Okay, let's say like so far we have discussing about three different methods being executed by three different threads. Okay, method 1, method 2, method 3. I said hey, T1 is responsible to invoke the method 1, T2 is for method 2, T3 is for method 3. Fair enough. Okay, so because it's not the same piece of code I'm executing by more than one thread. Each thread has their own logic defined in separate thread. But if I have a scenario like method 1 should be executed simultaneously by three threads, same piece of code needs to be executed by different threads. Okay, so let's say like no, this is what I'm trying to do here. Okay, the problem is, suppose this method 1 you're trying to do some kind of okay, what I can say, you're trying to read, okay, from a database, then and store it in a program variable, let's say. Okay. Or let's say other way around. Okay, you are writing the data into DB. If it makes sense, one second, let me think about it. I wanted to show you one real-time scenario. Okay, let's take the concept of check number. Okay, check number printing. What happens? It check number is always it's unique, right? The check number gets changed 1, 2, 3, 4 like that, right? Suppose if the check number is 1001, it should print next 1002, next 1003 like that, right? Okay. So what this check number does is basically come on, yes. So it reads the next available check number. Okay. Prints the check, then increment the check number by 1 and stores in the DB. So first it reads DB to get the next available check number. Okay, then prints it, then increment the check number by 1, then stores in the DB. So basically my method is doing these 4 steps. Okay, so 4 steps it is doing. Let me I don't know how this alignment here, right? Okay, wrap the text. Okay, so let's say like the same method being executed by 3 different threads. Okay, now see my T1 started first. Okay, and it read the check number 1001, let's say available in the DB. Okay, and it is trying to print 1002. Okay, print in the check number 1002. Okay, at the same time the T2 is executing. Okay, and it read. So basically what happens after printing the check number, the T1 is supposed to be updating the check value to 1002 so that the next thread can pick up 1002 and print 1003. But here T1 thread, it taken 1001 check number, okay, incremented by 1, then printed 1002. Before writing this 1002 value in the DB, T2 start executed. What happens? T2 again reads the check number 1001 and again prints 1002, which is not a valid process, right? Ideally my T2 should pick up 1002 and then increment by +1 and then it should print 1003. But what happened, since I executed these 2 threads simultaneously, so before completing this complete set, okay, the T2 got executed and picked up the same check number. So that means the threads are trying to use the same set of code. There is a fair chances of synchronization issues, means data discrepancies. So in order to avoid these kind of issues, we have the concepts of called synchronization. Synchronization means at a time, okay, you are restricting only one thread to access that particular piece of code. That way, nobody can access the data and you can also avoid the data discrepancy issues. So if you want to do that, right? See, remember guys, you don't need to mention that, this Entire code has to be locked, because suppose you have some 5 statements which does some general processing. Then you have these 5 statements to read the check number, print, and increment. Then you have 5 more statements for finishing up the thread. Okay, so basically whichever the code you wanted to make it to be available only for one thread at a time, you have to use the concept of called lock. When you say lock, that particular piece of code is executed by only one thread at a time. More than one thread cannot access the thread. Okay, so this is what I'm trying to say. So you lock the object and complete your set of statements. That way only this piece of statements are always being locked and only being executed by only one thread at a time. Okay, so I have programs. If you want, I can show you that. Okay, here you see I have 3 threads: thread 1, thread 2, thread 3. Okay, I'm starting thread 1, 2, 3. Okay, I purposefully kept sleep between 2 statements, right? Welcome to the world of .NET, and I put a sleep. Okay, so basically I should be printing welcome to the world of .NET 3 times, because I have 3 threads, right? 3 threads. I'm printing welcome to the world of .NET. Okay, I purposefully put a sleep to show you the difference. You see, it's very, very bad printing. You see, welcome to the world of .NET, and here it printed. So it is ideally my expectation is to print this welcome to the world of .NET 3 times, but it did not print because more than one thread is trying to access. Okay, and I did not get the desired results. Okay, because ideally I want welcome to the world of .NET 3 times. Okay, suppose if I keep the same piece of code using lock function, I'll tell you real-time scenario with about the ticketing concept tomorrow, but just for a generic understanding. Okay, now you see I have thread 1, thread 2, thread 3. Okay, and I've started 3 threads. Okay, you see here I said lock object. When I say lock object, okay, unless it executes this piece of code by one thread, it won't give chance for another thread. Let's see. You see, it is printing the way I want it. So first T1, I'm assuming first thread got here. Whoever the thread got first time, whether it is thread 1, thread 2, thread 3, it logs, and that thread completes the execution. Then it releases. Since this code is over, then it will unlock happen automatically. Then second thread comes, logs, prints, unlock. Then third thread comes, logs, print, then unlock. Okay, so basically if you have some critical statements which you don't want to give control to be accessed by more than one thread at a time, you keep that particular piece of code using lock, so that only one thread can access at a time. Okay, so I will show you this like in real-time example about the ticketing concepts. Okay, like the classic book my show example. I will show you like how the ticketing works with this locking, and how it works without locking. Okay, so I wanted to stop it here, and I will see if you have any questions before we wrap up the call. Any questions from today's session? And I'm going to share this deck and programs tomorrow, once I'm done with this multi-threading.
Yeah, okay, Anna.
Okay. All right then. Okay. So thank you very much. And we'll meet tomorrow same time.
Yeah, thank you, Anna.
Okay.
Thank you very
Yeah.
much.
Yeah.
Bye, Anna.
Thank you very much. Yeah. Yeah. Thank you.